Alright, so for the next couple of videos, we're going to look at how to do these Lewis structures for all these compounds, as well as figuring out the ABE notation. I think we told you to cross those guys out and call that ABE. And then how that corresponds to our predicted geometries, whether it's going to be bent, linear, those sorts of things. And to find out whether it's polar. So the first one I believe we did in class, but let's just for kicks do it again. To do the math, and I think on the quiz I give you a little bit more room than what we have here. How many do we actually have, or I'm sorry, how many electrons would we love to have? That's a little heart. We have 1 phosphorus. Phosphorus would love to have 8 valence electrons. We have 3 hydrogens. Hydrogen would love to have 2 valence electrons. This becomes 8 plus 6, or 14. We actually have 1 phosphorus. Phosphorus is in group 15, so it has 5 valence electrons. We have 3 hydrogens. Hydrogen is in group 1, so we have 3 valence electrons. Sorry, we have 1 valence electron. 3 plus 5, that's going to give us 8. Then we do our math to subtract this, and this will give us 6. 6 shared electrons. To figure out the number of bonds that we can get with 6 shared electrons, we just divide that by 2, and that'll give us 3 bonds. So our Lewis structure, hydrogen will never go in the center because it only wants 1 bond. So we'll put phosphorus in the middle. We'll put a hydrogen on each side, and then we need a 3rd hydrogen down here. Could have put it up here, that's fine. And now let's just connect everything with single bonds. And notice we've taken 3 bonds, and that's how many bonds that this compound has. If this were 4 bonds, maybe we would just take one of these and make them a double bond. Now it's our goal to go around and make sure everything is happy, and then we do that by putting electrons in the outer shells to give it 8. And so for phosphorus, there's 2 from this bond, 2 from this bond, 2 from that bond, for a total of 6. And then we've got 2 more electrons that we have to add to it to make it happy. So now in terms of our ABE notation, A will always stand for our central atom, so we're just going to rewrite P as A. And then B is going to be how many atoms are attached to our central atom. So I've got 1, 2, 3 hydrogens here, so that's AB3. And then our E corresponds to the number of lone pairs of electrons. A lone pair of electrons are electrons that are not attached to anything other than 1 atom, and it's only the central atom that we care about here. So we have 1 pair of electrons not bonding, or non-bonding, unbonding pairs of electrons. So our ABE notation would be AB3E. And then we go to find out what shape that corresponds to. Turns out that we look to our sheet, trigonal planar would be the shape that corresponds to an AB3. Now we're going to figure out if it's polar or not. So we come back to here and we find out what types of bonds we have. Well, we've got bonds that connect phosphoruses to hydrogens, and that's it. All of these are essentially equivalent. So we have phosphorus to hydrogen bonds. Then we look to our periodic table that has the electronegativity values on it. So let me get mine handy. That's the one I handed out, but you'll have it on a test or a quiz. Phosphorus has an electronegativity of 2.1. And then we're going to subtract from that the electronegativity of hydrogen, which is also 2.1. So our electronegativity difference is 0. So also on the sheet that has the ABE notations, I give you how to identify polar, nonpolar, and ionic bonds. And it turns out when we have a difference of 0, the bond is nonpolar. So that doesn't necessarily mean that we have a nonpolar molecule. So we go to our flow chart. First question our flowchart asks us is there a polar bond? Well, no. So that means the compound itself is nonpolar. We're going to do another example or two where we have some polar bonds that might not make it a polar molecule. So stay tuned for the next video.